Welcome to the section on sum and difference formulas. And here's what I'd like to say first. Be familiar with them. However, you don't need to memorize them. Instead, recognize the certain patterns and know where to find them, for example, in the beginning or end of your book. Respectively, I wrote them down here and how to use them. Perhaps in your book it says sine A plus B equals, and then it says on another line sine A minus B equals. Here, I recaptured them both together. No, see, as you see, you can, I'm sorry, as you notice, there's a certain pattern to them. So sine A plus B becomes a sine cosine plus cosine sine. The plus goes with the plus. For the cosine A plus B is cosine cosine minus sine sine, and then the cosine A minus B is cosine cosine plus sine sine, and that's what we'll be using. The tangent, again, get somewhat used to it. Recognize the pattern, find them, and apply them. Let's do our first example. Find the exact value for cosine of 75 degrees. It says exact value. Well, we can type it into the calculator, but that's going to give us the decimal number, and it's not going to be an exact one. So what they mean here is with the square roots and so on. We have not encountered cosine of 75 degrees. We only know special angles of 0, 30, 45, 60, and 90 degrees. But what we can do here is we can take the 75 degrees and split it up into something. Let's see what we can get. We could, for example, say that 75 is the same as 45 plus 30. Right, exactly the same. And this is where the sum and difference identity come in. I also need to mention here, I'm just going to do a number of examples. The proof for these should be in your textbook, and so therefore I'm going to spare the proof here online. In any case, so now I have cosine 45 plus 30, and now I'm going to look here, then I say cosine A plus B equals cosine A cosine B minus sine A sine B. So that's what I'm going to write down. Cosine, maybe I'll do this on the next line, equals cosine A cosine B, this time minus, the plus turns into a minus, sine A sine B. And now I'm going to plug in these numbers, 45 for the A, 30 for the B. So there we go. And now I can operate with that because I have memorized the special angles. Cosine of 45 degrees, of course, is square root of 2 over 2 times square root of 3 over 2. I don't even need to double check those numbers. Minus square root of 2, let's see, square root of 2 over 2 times 1 over 2. Okay, let's see what we come up with here. The first one is going to be the square root of 6 over 2. Let's see, square root of, oh, square root of 6 over 4. Yeah, square root of 6 over 4. And then we have minus square root of 2 over 4. So this one here. Square root of 4 over 2, which of, oops, square root of 2 over 4 the other way around. And that, of course, comes out to the following. Both have the same denominator. And so we have square root of 6 minus the square root of 2 in parentheses, divide by 4. And I believe there's nothing with which we can simplify that. At this point, I could go to the graphing calculator and actually check the result. However, I'm going to leave that for the problem sections. Okay, let's do the next one. Rewrite the following as a single cosine or sine. Let's figure out which one of the two. Here's cosine cosine minus sine sine. Cosine cosine minus sine sine will become a cosine a plus b. So that's what I'm going to do. Cosine a plus b. Before I proceed, though, I have to be careful and pay attention to that truly we have the correct arguments in here, so that we have an a, b, so that they match. 3x, 2x, 3x, 2x, just like it says here. A, B, A, B. If that's not the case, I will show in just a moment. We should be not touching that. So here, my cosine of 3x plus 2x, and if you really want to, you can write down that's cosine of 5x. All right, here it is. There you go. Okay, here's an example of what not to do. Let me actually copy these here so we can see them. Let's see, I think I finally got it. So the previous one, rewrite as a single cosine. Now this one here, cosine 3x sine 2x minus sine 3x sine 2x. Why do I say don't touch it? Because it doesn't match any of the patterns. It says cosine sine, sine sine. You don't see that. You see either cosine cosine, sine sine, or you see the mix as sine cosine, cosine sine, but not kind of like a double mix here. So don't touch this. That's why I say that here. Here, we have a cosine, cosine, sine, sine. Well, that may match this one over here, but notice that the A and B are not matched. So we have 3x, 2x, but then we have 3x, x. That doesn't match, therefore don't touch it. There's no way you can simplify any one of the two like you did a moment ago. Notice that we use this one here, and we simplified it quite a bit down to something really nice. Here, don't do it. There is no way. This one, don't do it. There's no way. Okay, one more exercise, example, excuse me. Find the exact value of pi over 12. As in an example before where we had cosine 75 degrees, where we split the 75 degrees into 30 plus 45, we may want to do that here too. Split the pi over 12 into two parts that we're familiar with. However, we're not, at least I'm not really totally familiar with the radians anyway, so I may want to keep it in my mind, back of my mind, that pi over 12 is the same as 15 degrees. So I keep that in the back of my mind, that pi over 12 is 15 degrees. How do I split up 15 degrees? Well, I have 45 minus 30, for example. So in radians then, that is going to be pi over 4. I'm going to be writing this here. Pi over 4 minus, well, 30 degrees is pi over 6. Is that the same as pi over 12? Well, it should be, because this one is 45, this one is 30. Subtracted 2 is 15 degrees, just like pi over 12 is 15 degrees. Or if you combine the fractions, you're going to have 6 pi minus 4 pi over 24, which is 2 over 24, which is 1/12, just like it should be. So from here, we can now proceed. Equals. Okay. I don't necessarily want to have it in black and small case. There we go. And I want to have it in bold. It just played a trick on me here, or it did. Okay. So I have sine A minus B. Sine A minus B is going to give me sine cosine minus cosine sine. So I'm going to say sine A cosine B minus cosine A sine B. And now I'm going to put these in here. That's the A. That's the A. I don't know why it's doing this. First time I've encountered that Word is doing something strange like this here. Make them larger. There we go. Better. Okay. That equals sine pi over 4, of course, is the square root of 2 over 2. Square root of 2 over 2 times cosine of pi over 6, cosine of 30 degrees, which is square root of 3 over 2. Cosine of 3 over 2 minus cosine of pi over 4 is square root of 2 over 2 times sine of 30 degrees is 1/2. I get square root of 6 over 4 minus the square root of 2 over 4. That really seems like what we had earlier. In fact, that's exactly what we had earlier. So I'm just going to copy these down. I just mentioned them correctly. So again, we have square root of 6 over 4 minus square root of 2 over 4, and then square root of 6 minus square root of 2 in the numerator over 4. And again, from here on, there's nothing to simplify. Again, in the problem section, I will actually check these on the graphing calculator. With that, I finished the lecture on sum and difference formulas, and once again, don't memorize them. Just know where to find them, then use them and recognize the patterns and apply them correctly, and don't apply them to something that would not work. I'm done.